2's plasma science instrument on September 26, 2024, to conserve energy. Then it turned off Voyager 2's low-energy charged particle instrument on March 24, 2025. That left 3 science instruments still running on Voyager 2, the cosmic ray subsystem, the magnetometer, and the plasma wave subsystem. Voyager 1 was going through the same kind of triage. Its cosmic ray subsystem was shut off on February 25, 2025. Its low-energy charged particle instrument was turned off on April 17, 2026. NASA's official status page says Voyager 1 now keeps only its magnetometer and plasma wave subsystem operating, while Voyager 2 still has 3 science instruments on. The plan NASA described in 2025 was to keep at least 1 instrument alive on each spacecraft into the 1930s if possible. That is not a promise, it is a fight. Suzanne Dodd, the Voyager project manager, said the Voyagers have been deep space rock stars since launch, and the team wants to keep it that way as long as possible. But she also said the electrical power is running low. If the team did not shut instruments off when it did, end of mission could have come within months. Linda Spilker, Voyager project scientist, put the emotion of it even more clearly. Every day could be their last, but that same day could also bring another interstellar revelation. That line matters because it captures the emotional truth of the mission. And those signals are unbelievably faint. This part of the story often gets skipped, but it should not, because it changes how you think about every bite Voyager sends home. NASA uses the Deep Space Network to talk with the Voyagers. That network is made of giant antenna complexes in California, Spain, and Australia. As Earth turns, one station after another can point toward the spacecraft. Without that global setup, contact would break for long stretches. These dishes are enormous, and they have to be. By the time Voyager 2's radio signal reaches Earth, it is absurdly weak. NASA has described the effort required to catch it as the work of a purpose-built system designed to listen across distances so huge they almost stop sounding real. A signal leaves a spacecraft smaller than a car. It crosses more than 13 billion miles. It reaches Earth after roughly 19 hours of travel, and then it still has to be separated from background noise, amplified and decoded into numbers that scientists can use. Imagine whispering from one side of a continent and being heard on the other side only because someone built a machine sensitive enough to detect the whisper from the storm around it. That is the scale of what is happening, and the distance keeps growing. As of NASA's 2026 mission status, Voyager 1 is heading toward a milestone no human-made object has reached before. On November 18, 2026, it will become 1 light day from Earth. That means light, the fastest thing in the universe, will need a full day to cross the gap between us and the spacecraft. Voyager 2 is closer than Voyager 1 because it took the longer route through Uranus and Neptune, but it is not far behind in spirit. NASA's current figures place it over 13 billion miles from Earth, with a one-way signal time of about 19 hours. Pause on that for a second. Every command sent to Voyager 2 is old by the time it arrives. Every answer comes back from a past moment. There is no real-time conversation anymore. There is only patience, silence, and delay. Humans ask a question across almost a day of light travel. The spacecraft answers nearly another day later. The mission unfolds like a conversation inside a dream where every reply has to cross an ocean made of time. And still, Voyager 2 answers. Here is another twist. That is a huge change in how a species understands where it lives. It is like growing up near a shoreline no one has ever walked to, only guessed at from far away, then finally sending 2 travelers to touch the water and report back. One says the surf is colder and stronger than expected. The other says the line between sea and land is sharper than the old map showed. Suddenly the border is no longer an idea. It is geography. Voyager 2 gave us that kind of geography. And because it did, people started asking the next question. If 2 accidental pioneers taught us this much, what could a mission built for interstellar science from the start teach us? For years, NASA and Johns Hopkins Applied Physics Laboratory have studied a proposed follow-up often called Interstellar Probe. The idea is simple and enormous at the same time. Build a spacecraft specifically designed to go beyond the heliosphere on purpose, faster and better equipped than Voyager, carrying instruments meant from day one to study the boundary region, the outer heliosphere, and the nearby interstellar medium. As of now, it remains a concept, not a launched mission, not an approved replacement already waiting in the wings. That last point should sit with you. There is no active handoff happening right now, no younger spacecraft already arriving to take over, no modern twin waiting just beyond the door. The only machines currently sampling interstellar space directly are the Voyagers. When they finally fall silent, a unique window closes with them. If hidden stories like this are why you come here, subscribe now, because we are only getting deeper into what these old spacecraft are really telling us. Now we have to talk about the part of this story that feels personal, even if space usually seems too large to touch your daily life. Why should you care if a 50-year-old machine on the edge of the heliosphere loses power? Because stories like Voyager's remind you of what human beings are at our best. We are fragile. We are short-lived. We argue, get distracted, and fill our days with things that feel urgent until history shrinks them. And yet, somehow, a group of people on one small planet built a pair of machines in the 1970s that are still carrying our curiosity farther than anything else we have ever made. Think about the age of the technology involved. These spacecraft were designed decades before modern smartphones, before the internet as most people know it, before so much of the software world we take for granted. And still, they survive. Still, they adapt. NASA has repeatedly reworked how the mission is run, reshuffled power priorities, and found ways to keep science going from hardware that already outlived its design by many decades. That is the underdog part of this story. Not sleek, not new, not flashy, just stubborn. A little machine the size of a small car, carrying outdated systems by today's standards, still doing work no advanced replacement has taken over, still pushing through cold darkness, still reporting from outside the sun's protective bubble. If that does not move you, I do not know what will. And here's the part they do not always explain when they summarize Voyager in one line. The odds of either spacecraft ever being found are thought to be incredibly low. The space between stars is unimaginably empty. There is no target star they are aimed at, no planned meeting, no destination where a receiver waits. They are messages in bottles tossed into an ocean so large that even that metaphor feels too small. And still we sent them. That tells you something important about our species. We are the kind of beings who write letters to the unknown, even when we believe no one may ever read them. We are the kind of beings who send music, greetings, images, and maps of our own bodies into darkness simply because the darkness is there and because silence alone feels incomplete. But Voyager 2 gave us something in return too. Not comfort exactly, something truer. It gave us a sound that says the universe is not empty in the way our fears imagine. There is structure out there, pressure, density, fields, motion, boundaries. The space between stars is not dead stillness. It has texture, it has behavior. It can push back against the sun's giant bubble and shape it. It can make old spacecraft sing in data if we know how to listen. That is why the fake headline version of this story bothers me. And the clock is running. NASA's own planning makes that plain. After the 2025 power-saving changes, Voyager 2 still had 3 operating science instruments, but another shutdown was already on the horizon. The cosmic ray subsystem on Voyager 2 was expected to be the next science instrument turned off in 2026. After that, if things held together, the magnetometer and plasma wave subsystem would continue for as long as the remaining power allowed. The goal was to stretch the mission into the early 1930s with at least one instrument still working. Notice the language there. Goal. Stretch. If things held together. Nothing about this is guaranteed. Deep space is harsh. Hardware ages. Heaters fail. Thrusters clog. Communications grow harder. Even the ground systems on Earth that support Voyager face their own limits and maintenance windows. Keeping contact with a spacecraft across these distances is an act of constant care, not automatic magic. So when mission scientists say any day could be the last day, they mean it in a practical way, not a dramatic one. A fault that would be frustrating on a newer spacecraft can become mission-ending on one this old. A power drop that seems minor on paper can force one more permanent goodbye to an instrument that will never wake again. That is why the story feels so human. Voyager 2 is surviving by subtraction. To keep speaking, it must slowly become less than it once was. Fewer tools, fewer options, less flexibility, less power. And yet, every part that remains grows more precious because it continues to work against the odds. That is a hard kind of beauty, maybe the hardest kind. There's also a quiet lesson here about science itself. Real discovery is often slower than headlines want it to be. Voyager 1 crossed into interstellar space in 2012, but scientists needed time, multiple measurements, and later plasma wave evidence to feel sure. Data had to come down. It had to be processed. It had to be compared. Papers had to be written. Claims had to be checked. That can look boring from the outside if you expect instant cosmic drama. But that slow care is exactly why the results matter. When NASA says Voyager 2 crossed the heliopause, it is not because someone liked the story. It is because several instruments agreed. When scientists say the plasma beyond the heliosphere is denser, slightly compressed, and unexpectedly warm in places, it is because real measurements support that picture. When they say the sound made from the plasma data reflects actual frequencies in the environment around the spacecraft, it is because those frequencies were measured, not imagined. This is the part nobody talks about enough. Truth in space science is often weirder than hype, but it asks you to be patient. It asks you to accept uncertainty when uncertainty is honest. It asks you to sit with numbers long enough for them to become wonder. Voyager 2 rewards that patience. Because once you strip away the fake mystery, the real mystery comes forward. What else is waiting out there in the near interstellar medium? What will the plasma wave instrument still hear as solar disturbances roll outward and stir the gas around the probe? What can the magnetometer tell us about the magnetic shape of this boundary region over more time? How long can an artifact of the 1970s keep extending the frontier of 21st century science? No one knows. And that is the best reason to keep listening. That symmetry is almost too perfect. On one side, the noise of our world. Greetings, songs, breath, water, life. On the other side, the hum of a colder, denser medium beyond the sun's bubble. A machine sits between them, carrying both stories at once. Maybe that is why Voyager 2 feels different from so many other missions. It does not only show us worlds, it connects scales, the living room where you watch this, the giant bubble around the solar system, the thin gas between stars, the decades between launch and now, the shortness of a human life against the length of a billion-year drift. All of it touches in one line if you follow the signal far enough. Right now, while you are watching this, something tiny and man-made is still moving through a place almost no human being ever thinks about. It is older than many parents, weaker than a dim bulb, and farther away than the mind likes to picture. It should have died a long time ago. It did not, and years after it crossed the last real edge of the sun's influence, it sent back a signal that scientists turned into a sound no one had ever truly heard before. Once you understand what made that sound, this story stops feeling distant. This is the hidden story of Voyager 2. Welcome back to Proof, where we uncover the hidden truths of the cosmos. If you are new here, subscribe now, because what you're about to hear is one of those quiet space stories that feels almost impossible once it starts sinking in. Voyager 2 is not racing through some empty cartoon version of space. It is out there right now, more than 21 billion kilometers away, still speaking to Earth in a voice so faint that whole networks of giant antennas have to lean into the dark just to hear it. And here's the strange part. The most haunting thing it has told us is not a picture, not a video, not a dramatic final message. It is the electrical trace of the stuff between the stars. Drop a comment right now and tell me where you are watching from. Because I always love seeing how many corners of Earth are listening to stories like this together. To understand why that matters, you have to go back to the beginning, before Voyager became a legend, back when it was just another machine with a deadline built into it. Voyager 2 launched from Earth on August 20th, 1977. Its twin, Voyager 1, followed a little over 2 weeks later. The original plan was bold for its time, but it was still small compared with what the mission became. Fly past Jupiter, fly past Saturn, send back pictures, measure the planets, their moons, their rings, and their magnetic fields, then, eventually, fade out. That was the expectation. These spacecraft were not built with the idea that children, not yet born in 1977, would one day grow up, have families, and still hear updates about them. But space gave NASA a rare chance, and NASA took it. The outer planets had lined up in a way that almost never happens. Roughly once every 176 years, Jupiter, Saturn, Uranus, and Neptune sit in positions that let a spacecraft use each world's gravity like a moving slingshot. Instead of carrying enough fuel to force its way to each planet, the spacecraft can steal a little energy from one giant world and fling itself toward the next. That trick changed everything. It turned a short mission into the Grand Tour. And Voyager 2 became the only spacecraft in history to visit all 4 outer planets up close on one trip. That fact alone would have been enough to make it famous. At Jupiter in 1979, Voyager 2 helped reveal a world more violent and alive than many people expected. It saw storms, lightning, and a moon system full of surprises. At Saturn in 1981, it sharpened our view of the rings and the moons circling that pale giant. Then came the decision that made Voyager 2 truly unique. Instead of ending the mission after Saturn, NASA sent it onward, deeper into the outer dark, toward Uranus and Neptune, places no spacecraft had ever reached. That choice sounds obvious now because we already know what Voyager 2 found. Back then, it was a gamble. Every extra year in deep space meant more risk, more chances for a system to fail, more ways for a mission to end far from help. But the engineers and scientists pushed anyway, and because they did, Voyager 2 reached Uranus in 1986 and Neptune in 1989. No one has gone back since. At Uranus, Voyager 2 found new moons and previously unseen rings. It showed us a tilted world that looked calm from far away, but made less sense the closer scientists looked. At Neptune, it found something even more dramatic. A giant storm swirled through the atmosphere, dark and massive, so large it could swallow Earth. Later, people called it the Great Dark Spot. Voyager 2 also confirmed Neptune had rings of its own. These were not guesses from a telescope on Earth anymore. They were close-up facts delivered by a spacecraft speeding through a place humans had never touched. Then the cameras went dark. That moment matters more than it seems. After Neptune, there were no more planets ahead, no more moons waiting for portraits, no more bright targets worth spending precious power on. So the imaging system on Voyager 2 was turned off in 1989. The spacecraft would never take another picture. That sounds sad at first, but in a strange way, that was the beginning of its real secret life. because once the planetary tour ended, Voyager 2 stopped being mainly a camera and became something else. It became a listener. Bolted to its side, even then, was one of the most human objects we have ever sent into space. The Golden Record. A gold-plated copper record made for any finder so distant from us that they might never know we existed otherwise. A team led by Carl Sagan helped put it together. It carried greetings in many languages, music from different cultures, sounds from Earth like thunder, wind, and whale calls. It carried images, too, encoded in a way someone else might be able to reconstruct. Human bodies, streets, diagrams, life on one small world. And this is where the story changes shape. Most people think of the solar system as a set of planets around the sun. That is true, but it leaves out the invisible structure that wraps around all of it. The sun does not only shine, it also blows. It constantly throws out a stream of charged particles called the solar wind. That wind pushes outward in every direction, carrying part of the sun's magnetic influence with it. Over enormous distances, that outflow carves out a giant bubble in space. That bubble is called the heliosphere. Inside it, the sun still rules. Its wind, its magnetic reach, its protective influence. Outside it, space belongs more to the galaxy than to our star. That boundary matters to you even if you never think about it. The heliosphere helps shield the planets from a huge share of high-energy radiation coming from outside our solar neighborhood. It is not a perfect wall. It leaks. It shifts. It breathes in and out as solar activity rises and falls. But it still acts like a protective frontier. So when scientists talk about Voyager 2 reaching the edge of the heliosphere, they are not talking about some abstract line on a map. They are talking about the outer edge of the sun's direct hold, the point where the space environment around us starts becoming something else. For years, scientists were not sure what that edge would really feel like. Some thought it might be a broad, fading zone, a slow change stretching over a long distance. Others suspected something sharper, but no one knew. There was no way to know from Earth alone. Voyager 1 got there first. In August 2012, Voyager 1 crossed into interstellar space. It did not mean it had left the solar system entirely. That is a different claim, and people mix the two up all the time. The sun's gravity reaches much farther, all the way out toward the distant cloud of icy objects at the solar system's fringe. But Voyager 1 had crossed the heliopause, the boundary where the solar wind stops dominating and interstellar space begins. That alone was historic. It was the first human-made object to enter that region. Still, one spacecraft can always leave doubts behind. Maybe Voyager 1 had passed through an unusual patch. Maybe its path was special. Maybe the boundary looked that way only from one angle. Science does not like to call one sample the final answer. If a second sample might change the whole picture. That is why Voyager 2 mattered so much. It was coming in from a different direction. It had taken a different route through the outer planets. It was traveling through another part of the sky. And unlike Voyager 1, it still had a working plasma science instrument, one of the tools best suited to measure conditions in the space around it. If Voyager 2 found a similar crossing, then the idea of a real boundary would become much stronger. If it found something wildly different, then scientists would have to rethink what the edge of the heliosphere even was. On November 5th, 2018, the answer arrived. Voyager 2 crossed the heliopause and entered interstellar space. It was about 11 billion miles from Earth, and the signal coming back took around 16 and a half hours to travel home. 4 different kinds of measurements told the team the same thing at once. Solar particles dropped. Cosmic rays from beyond the heliosphere surged. The magnetic environment shifted, and the plasma science instrument saw the solar wind fall away. This was not a vague hint. It was a physical crossing into a new region. 1 year later, 5 scientific papers in Nature Astronomy laid out what Voyager 2 had found. Together, they showed something important and strangely beautiful. The boundary was real. It was not just a story we told ourselves about where the sun's power faded. It was a measurable frontier, and beyond it, the plasma was denser than inside the heliosphere, colder overall, but with signs of unexpected compression and warming that suggested the outer shape of the sun's bubble was more complicated than older models had assumed. Here's the twist that takes this from interesting to unforgettable. One of Voyager 2's instruments helped scientists turn that crossing into something you can almost feel in your own body. The instrument is called the Plasma Wave Subsystem. That name sounds technical, so let's make it simple. Space is not truly empty. Even in the darkness between stars, there's thin gas. Some of that gas is plasma, which means its atoms are charged because electrons have been stripped away. Charged particles can wobble, vibrate, and oscillate in ways that create electric signals. Voyager's plasma wave instrument does not hear sound like your ears do. It measures those electrical oscillations in the plasma around the spacecraft. And here's the part that people keep getting wrong. There is no normal sound in open space because there is no air there to carry pressure waves, the way air carries your voice across a room. So, when you hear people say NASA recorded sound from deep space, it can sound fake. It can sound like movie science. But this case is different. The spacecraft measured real plasma oscillations. Those oscillations happened at frequencies that overlap with the range. Human ears can hear if you convert the data into audio. Scientists did not add a melody. They did not hide a voice inside static. They took the actual measured frequencies and played them through a speaker. What came out was not music. It was a tone, a hum, a ghostly shift in pitch that carried physical meaning. When Voyager was still inside the heliosphere, the tones linked to plasma activity sat lower, around a few hundred hertz. Once Voyager crossed into interstellar space, the frequencies jumped higher, into the range of a few thousand hertz. That jump mattered because pitch here was not just a spooky effect. It was evidence. Higher frequency meant denser plasma around the spacecraft. In other words, the sound itself helped show that Voyager had moved into a different environment. Don Gurnett, the University of Iowa physicist who led the plasma wave investigation, said those sounds were solid evidence that Voyager 1 had left the heliosphere. NASA explained the same idea clearly. The pitch and frequency told scientists about the density of the gas around the spacecraft. So the so-called sound of interstellar space was not a gimmick laid on top of the science. It was the science made audible. That alone would be enough to send chills down your spine if you stop and think about it. A machine built in the 1970s, still alive across a gulf of darkness, measuring the electrical behavior of charged gas between stars, then setting the numbers home so human beings on Earth can listen to the structure of another region of space. Not imagine it, listen to it. But that is not even the strangest part. Voyager 2 helped confirm that Voyager 1 was not seeing a one-time fluke. NASA said the two spacecraft independently showed that local interstellar plasma was significantly denser than the plasma inside the heliosphere. Voyager 2 also found the plasma beyond the boundary was slightly warmer than expected. That may sound like a small detail, but it matters. It hints that the heliosphere may be getting squeezed unevenly by the material beyond it. In plain language, the bubble around our solar system might not be smooth or balanced. It may be pushed harder on one side than another as the sun moves through the galaxy. Think about what that means. This is where a lot of videos start drifting into fantasy. They call it a terrifying message. They hint at alien code. They frame a measured plasma signal like a hidden warning NASA was too afraid to reveal. That is not what happened, and honestly, the truth is better. The real story is that something more unsettling than a fake transmission is happening. Humanity has built only two machines that have ever entered interstellar space. Both are old, both are fragile, both are running out of power, and one of them, Voyager 2, is still telling us what the edge between the sun's world and the galaxy beyond it actually feels like. That is where the countdown begins. Voyager 2 is powered by a radioisotope system. Again, that sounds heavy, so here is the plain version. It uses the heat from decaying plutonium to make electricity. It was never going to last forever. NASA says both Voyagers lose about 4 watts of power every year. 4 watts may not sound like much, but on a spacecraft this old, that loss is constant pressure. Every year the team has a little less to work with. Every year they have to decide what to keep alive and what to let go. Over time, that has meant turning systems off one by one. The cameras went first long ago because there was nothing left to photograph that justified the power cost. Other instruments followed over the years. Some were shut down because they were no longer useful for the region the spacecraft had reached. Others were turned off to save power. By 2024 and 2025, the choices had become painfully sharp. NASA turned off Voyager.